Hello, this is Alex from cables.gl. I think it's time we look at ammo physics as we know them, right? Things colliding, hitting each other, bouncing off, things that have a lot of weight might influence things that don't have that much weight a lot differently. And all this cool stuff is now in cables, and we can actually do quite fancy and cool simulations with it. And in our previous video, we looked at how do we use AmmoWorld and Ammo Raycast to pick and select things and interact with them with our mouse or maybe some other input, but precisely hit the kind of collision cage of an object. So if we have something like this coin, it's not like a square, right? It's going to be like a coin, and it will interact with other things in the way we sort of expect. So I'm going to show you some examples, and then we'll just get into the basics, and I'm going to show you how to set it up and how to connect things, and just to start playing around with maybe like a cube or something. But some of these things are already in our patch library, so you can play around with something I'm going to show you, and you'll find the links in the description. But okay, here we go. So what do we have here? We have a patch that has a pretty cool Japanese coin that is repeated a bunch of times, and with it being inside of AmmoWorld, we can start using physics and giving it some cool animation automatically. So if I press the right mouse button, if you see here, I connected it to my AmmoWorld for a reset. There it is. So when I press my right mouse button, I get coins dumped all over this little table I've made in the center of the screen. And in my sidebar here, I just connected a bunch of different parameters from the AmmoBody operator. So if we look at AmmoBody, and we'll zoom in on it. So we have a bunch of parameters in here that are quite important to making the simulation animate in a believable way, right? So if you have a small coin, maybe it shouldn't weigh like 1,000 or like a ton or something like that, and maybe it should have less friction than maybe sandpaper. I don't know. You can get into it with these parameters and actually get quite believable reaction from your 3D simulation. So we got mass, friction, rolling friction, and restitution. Mass, you can guess, of course, is the total like weight and density of an object. So maybe the coin is actually not featherweight. It has some heft to it, so you might want to dial something in. And then the friction, you also have to kind of think, okay, is it metal? Is it plastic? Is it something super light like a feather? Will it cling on or bounce off of things or slide on surfaces? And the cool thing is we have, of course, this little table I set up under the coins. And that is also a body here that has its own settings, right? And with a mass of 0, it doesn't really move anywhere. It's totally stationary. So if you've seen our previous videos with the rooms and the places where you can like walk around, the virtual spaces, we are using ammo bodies with 0 mass. So they're static, but they provide collision for other objects. So that way we can walk around these spaces, or maybe like toss balls against a wall or something like that, and it bounces back. So that's a pretty common way of making super static objects that are just like there. So that's what our table is, and it has its own friction and rolling friction and restitution. I'm going to tell you what these are actually. So friction, of course, is kind of like how slick is this object? Is it rough? Is it going to slide on surface? Just like what friction means. Rolling friction is how grippy is the object to then induce roll on the object. So it's kind of a bizarre, maybe like an ammo physics library only term, but you need to kind of play around with it. And maybe we'll play around with these sidebar settings here to see what they mean. And then restitution is, if you look it up, it's just the how much energy is put back into the object once it collides with something. So for example, like a rubber ball will retain quite a lot of energy, so it'll bounce right back at you when you drop it on the floor. And something like a hefty like iron bar will maybe stay on the floor a lot quicker. So we can play around with this in this little object example. So when I change the parameters, it resets the simulation. So that's pretty handy. So with a lot of mass, we get okay. See that right there is completely stationary because there is no mass on the object, so it's just floating in space. And then friction. Let's see what happens when we give it very little friction. See, it's as if the table is covered with like a soap or something like that, right? Restitution is, again, the energy. So if we give it a lot of restitution, then these coins are super bouncy, and then it starts to feel less believable, right? Because we don't expect that from coins. Okay, enough with this example. Let's look at what else we can do. We can have emitters that produce objects, and then we can play around with collisions between these emitted objects, which is really cool. This example, I'll link below. And actually, I don't think I'm going to go into the physics emitter stuff, ammo emitter stuff in this tutorial, but I think with what we will cover, it should be quite easy to figure out. And if you look at this patch, but I will cover it in another tutorial a bit later. So this is kind of cool, right? You can make some sort of toys, or maybe like create automatic cool animations of your objects, or some kind of generative things. So here we have the emitter slowly spinning around, so you get this like kind of cool pattern with these flying sticks. And then here, I think it was more of maybe a real world example. So I have, for example, this tape that I want to use as a product, or like as a little ad or something on my website, right? And I want it to fall into the camera view and look really cool, right? So I'm using the AmmoWorld and AmmoBody for this. And right now I have the simulation paused. And if you see over here, I have the keyboard button 1 and 2 to stop and restart the simulation of my scene here. So I have it set up, and let's simulate it, right? So the tape falls here, and maybe now that the interesting thing is with computer physics, a lot of the times if there aren't any random parameters introduced into the scene, you know, you have very precise things like this is the mass, this is how much friction there is. There isn't maybe like wind or slight tilts or stuff chipping away from your model or something like that. Unlike in our real world, you can predict exactly where this simulation will end up. So every time I reset the simulation, this tape is going to end up in the same location, just because all the settings here are static and I'm not changing them. You know, my tape is with specific settings for the friction and rolling friction and all that stuff. And so is this table that I have behind it. And so yeah, then I can, on the last kind of frame of the simulation, so to say, like once it kind of comes to a rest, I can pose my camera and then restart my simulation, and then maybe that could be part of a video or something like that for some kind of post, or I don't know, maybe like a website intro. And for example, if I don't like this, I can change the mass of the tape and then see how that affects my simulation. So maybe I want it, you know, jumping a bit more or something like that. So it's actually quite fun to play around with this as a sort of composition tool or an animation helper or something like that. You know, I wouldn't want to keyframe all of that. I just want to drop a tape on the floor, drop my hot mixtape, and then invite people to listen to the music or something like that. So I love this for animating just stuff for design. All right, so we looked at some examples, and now I'll show you how to set up a very quick scene where we're using AmmoWorld and a couple of ammo bodies to make a cube fall on the floor and bounce around a little bit, like so. See, so very, very simple scene, but I think it basically will teach you everything you need to know to then create all the other stuff I showed you earlier, and maybe help you make sense of the examples that are already in the library, make it a bit easier. So what do we have? We have main loop, orbit controls, directional light. That's quite standard stuff. I put in a directional light because I'm using Phong materials and I just wanted something else other than a default light. And then we have AmmoWorld, and then the floor and the cube are ammo bodies. Let's take a look at AmmoWorld, and it's actually quite a simple operator that, again, we need to set up first, and then all of the ammo physics library related operators underneath the AmmoWorld. So you see, I kind of like to do AmmoWorld and then a sequence to then space out the different physics objects and 3D models and things like that under the AmmoWorld. We have quite compact parameter panel here. We have a simulate toggle, which will allow you to maybe pause simulation if it's super heavy, or maybe you'll need to pause simulation when you maybe recalibrate some of your settings and then run the simulation again. But for the most part, with it on is fine. But then again, remember that it's there if you need to save on performance. Maybe you have an intro where the cube falls in, forms some sort of a logo, and then you can stop the simulation and then save on resources. Then we have gravity. Gravity is really cool because, of course, in our world, it's pretty much on the y-axis, right? We're pulled to the floor like this cube is pulled to this gray table rectangle thingy. But in a simulation, you can do whatever you want. So actually, the gravity I'm putting to almost like half or 1/3 of what it was, and then we do the simulation, and it changed a little bit. And we can maybe even get into like moon physics. See, it slows down a little bit. So, excuse me, we can get some very creative, cool effects with this, especially because we also have gravity on the X and Z axis. So if I manipulate this, I can even manipulate it live, right? So I'll show you with the Y so the cube stays in camera. So if I go into positive, it should float up, but it doesn't. Why doesn't it? That's because my cube AmmoBody operator is set to sort of defaults. For example, yeah, they're all very close to what it usually is, but this is what I'm talking about. The default is this, the flags parameters. We have active, which means, is it active in the scene? When we deactivate it, we need to actually reset our simulation. So there it is again. And then our gravity will be positive. And then back to the question, why is it not working? And it's never deactivate flag. This is kind of a smart feature of sorts of ammo physics library. The way it's implemented in cables is when the velocity and the kind of activity of an object with other physics objects is below a certain threshold, then the object goes to sleep, basically. And then it can be reactivated with like a trigger. See, for example, when we press it, the gravity starts to work on it. But it doesn't work on it to the point where the threshold is reached, so it keeps deactivating the object. So that's why we have this toggle, never deactivate. So now our gravity is affecting our cube, and then when I put it to -9, there it fell off the table somewhere. So anyway, pretty cool. We can use this never deactivate flag, and then of course we are constantly calculating the scene physics, so that might not be the smartest solution, but for certain effects, it's kind of cool where you can change the gravity live and maybe have it inside of like some bounds where it doesn't fly off your screen. You can do some really cool automated, animated gravity adjustment and things like that. So that's pretty much the AmmoWorld operator in full. And then we'll focus on this AmmoBody cube. Actually, you know what I'm going to do? I'm going to leave my floor, and I'm going to delete this pink cube and create it with you together. And before we do that, we'll look at the floor. So the floor has a mass of 0. And this causes it to stick in place because it has no mass. It has no interaction with the gravity. It's just there. But it is a solid. So other things that collide with it will collide it with it in a specific way due to the friction, rolling, and restitution and things like that, because it does affect the other object that collides with it. And then we have the box shape selected for it. And we can visualize this with the debugger too. Debug, Ammo debugger. And let me maybe disconnect this cube so we see just the wireframe. And hopefully you can see it on the screen. It's a bit thin, but I'll just quickly show you why it's handy. So right now we have a box with these settings, right? We have Y, which is the kind of height of this, and then the size Z and size X, affecting our bounding box cage, which is our collision mesh. And then if we switch to sphere, then we have a sphere that we can adjust the size of, cylinder, capsule, cone, and then geometry convex hull. And geometry convex hull is an automatic calculation of a collision mesh, so to speak, collision cage from an input geometry. So if we look at the AmmoBody input ports, we have this geometry input, and we actually have an error right now. Shape needs geometry connected. So we do not have anything connected, but we do want to use geometry convex hull, and it's complaining that we don't have that. So we'll go back to box, and there is our box. And then we have this very interesting output port called transformed, which I think is so helpful compared to if you've used the previous physics engine in cables. It had quite a difficult setup process, but now we have this kind of reimagined and improved, optimized way of fitting your graphical 3D model representations to the cage, collision cage. And this is this wonderful port out here, which is called transformed. So when we connect our 1 unit cube, if we go to the cube, it's 111. That's the 1 unit cube. It will use the size of the collision ammo body, which is fantastic, right? So everything matches up. The collision and the 3D representation of our object looks great. So back to creating a box that will fall onto this little platform. Let's add an ammo body. There we go. And we don't see it probably because it's inside this cube floor. So what can we do? We have our ammo body by default with a mass of 0. And whenever it's a mass of 0, again, it's a static object. And that is a fantastic time for us to use the transform to then adjust the location of our physics body. And I recommend you maybe plan ahead. For example, I want this box to fall from a certain height onto the floor, this gray floor here, and that's pretty much my plan. So I don't need to immediately give mass to my cube that's going to fall. I'm going to keep it at 0 because then it's a lot easier for me to visualize where my box will be and how it will shape or fit with the other shapes in my scene. Because of course we can give it mass and then we should see it bounce down, and our debug render is also showing the contact points, which is kind of cool. I'll turn them off for now, and then we'll talk about them later. So I have this box here. Let me just quickly add another cube under the transformed node, and then maybe give it a Phong material as well. Okay, so here's our little blue cube. And we have some mass, right? So now let me also do this. Reset will be mouse right button. Right click. So whenever I right click my canvas, I reset the simulation. So we have a box, but we want to change the starting location. So we can turn on the Gizmo views with these toggle helper menu, which appears when we click on the canvas in our editor. And then we can see whenever we select a transform where the starting position is. But I don't know, like sometimes it's helpful, but I kind of prefer to just turn off my mass and then position this box wherever it needs to be, because sometimes you have to like position it in between other objects that are collidable. So it's a lot easier than just like continuously restarting your simulation and going, okay, I finally found the right place for it. Because if you maybe put something inside of another object, it will just fly into space because of the insane collision it has, or the simulated physics interactions can be super wild. So basically, this is it, right? We have a box that falls, and we can like change the rotation of this box as well. So when we start the simulation, it has an initial rotation that will maybe affect the bounce a little bit more interestingly. And again, without this mass set to 0, it's a bit difficult to position this stuff. See, this is a lot easier though. Like I want it to bounce on the corner. I want it to be a little bit bigger. Like this, make it a weird stick thing. And then add some mass to then start simulating. Very cool. What else should I show you? I want to show you one more thing, which is using geometries, right? This convex hull thing. I think it's super, super neat. So I'm going to delete this thing and then keep my debugger on. AmmoBody, I'm going to switch to have 0 mass, and then I'm going to use this geometry convex hull. I have this alert again. Then I go to my files and maybe look at a bunny, this one. Then I'm going to connect our GLTF scene, render it. Don't really actually need it right now. I'm just going to turn off the render and then show structure and then get the geometry of this GLTF scene for the bunny. So just need the geometry plugged into here. And we see this green blob that is supposed to be the collision cage of our bunny, but it doesn't really look like our bunny. Okay, no problem. So what do? We have to pay attention to the simplify max triangles. So basically right now, this collision mesh of a bunny is super simple, made out of 50 triangles. And sometimes you do need that, right? You might not need super precise collisions for like the bunny ears and the tail and things like that. You just need like a approximate thing because maybe you have a bunch of them in the scene and it's really quick and whatever. But if we want to have more precision, we of course just increase our amount of triangles to maybe like 10,000, and then we will connect it again and then see what happens. It doesn't look all that much better, but that's actually the way convex hull works, right? Because let's look at this bunny. If we activate it again, maybe give it a material, and then move it into where we can actually see it. And right now it's also rescaled, I believe. So maybe we can turn off rescale, and then it matches up our collision mesh a bit more. I'm going to turn off this box below. Maybe reset our scene. Okay, so what's going on here? Why doesn't it look like our bunny? Well, because look at the bunny. It's actually, if you try to maybe imagine getting like a sheet of maybe paper or like butcher paper or something like that, or like plastic sheet that's quite like tough and thick, right? And then try to lay it over this bunny, try to wrap it. And this is basically what you're going to end up with. Like, try to wrap this bunny in a newspaper. And that's the convex hull, basically. So if you want to have the bunny ears defined, then you need to maybe break apart your 3D mesh into multiple objects that then will be calculated correctly and then represent this collision mesh a bit better. But I think we will cover this in a more specifically oriented tutorial where we're gonna maybe create like super precise collision meshes and maybe some simple ones for perhaps a 3D room tutorial. Maybe we can make one together and then roll some balls under chairs and tables and things like that, where this approach with creating a convex hull needs to be addressed in a special way. All right, so I hope you enjoyed that. Check out the documentation. Check out the previous tutorial for raycasting. I think it also kind of goes hand in hand with this stuff. It will allow you to do some crazy cool physics / interactive user interfaces in 3D. And yeah, check out the examples in our library. I'll link them below. Have fun and see you soon. Bye.